Hello, welcome back to LeetCode Daily Live, where I do the LeetCode Daily question raw and uncut. So let's get started. So we have yet another medium today. It is called find elements in a contaminated binary tree. So I think we'll switch topics from exponential problems to trees now, or maybe later on graphs. Yeah, let's look at the bounds again. So it looks like we are writing some class, and then constraints tree node dot value. Is it that all values are -1? I'm not sure, but let's just keep reading. The height is at most 20. The number of nodes will be 10,000. The total number of calls of find is also 10,000. So whatever find is, or init, it has to be on or on log n. The target, which is a number, right? Yeah, the target will be 10 to the power 6. So let's see what it wants. So given a binary tree with the following rules, so the value of root has to be 0 for any tree node. If tree node.val has the value x and tree node.left is not null, so the left exists, then tree node.left.val is equal to 2x plus 1, and I assume, yeah, so if there is a node on the right, then the value of that node will be 2x plus 2. So now the binary tree is contaminated. So that means every value has been changed to -1. And let's see what we have to do here. So we have to find elements. Find elements. It doesn't seem. Oh, right. That's just the class name. So that initializes. And then we have one function, which is find. It returns true if the target value exists in the recovered binary tree. Yeah, so I'm still a tiny bit confused, maybe, but let's see. So I'm guessing. Right, so I'm guessing that you're given a tree, and then basically it just like everything becomes like everything is contaminated, and like all the values become -1. But we are guaranteed that the start of the tree starts at 0, and and then like we just follow the rules. So right, so this is the initialization. This will be false because we don't have a left tree. And then and then for the right tree, we do have a 2 here. So the tree here really only, like, the only thing it does is that it works out whether it works out the original structure. So a very easy way to do this is we just go through like the whole tree initially, and then we store all the numbers that are actually in the tree. So if we think about it, the height is 20, right? So that means we are looking at around like 2 to the power of 20, for the value. And because of the +2, it might be a bit bigger, but like it wouldn't be bigger than like 2 million. So it is well contained for an int. So we're not dealing with like astronomically large numbers. So yeah, honestly, yeah, we can just loop through the tree, and then so what we can do is we have a scene set, and that's going to store all the that's going to store all the values that are in this tree. And then like when we do find here, Well, we can just check whether target is in scene. So yeah, it should be easy enough. So well, we want to loop through root, so we definitely need a helper function. So traverse node optional tree node, and we don't have to return anything. Do we? Yeah, I don't think we have to return anything. Yeah, so maybe it is more convenient to, so let's say, I don't know, you have a tree that looks like this, something like this. I think it is more convenient if you just check directly from the node whether like left and right exist, and then like you add that value in, and then you loop to like its children, and then like its children can look at its children, and then loop into those things. So I think like that would be the most convenient way to do it. So obviously we have the base case, which is if the node doesn't exist, well, we just want to return. So otherwise we know that the node exists, so we can do node.left and node.right. But we still have to check whether it exists first, right? So if it does exist, actually one thing we have to do, we want to set, but root could be optional. Let's see. Right, but the total number of nodes is, like, we have at least one node, so we guarantee that root is not actually optional. It is a tree node. And what we can do is we can just do root.val 0, and then, yeah, and I think we want to do self.scene. We want to add 0 in first. Yeah, and then, so I'm just thinking like from the root, like because root is an edge case, right? Like there are no preceding node for roots. So like we have to think about that as well, and think about the most convenient way to do that. So if node.left, so the left node exists, well, we want to do self.scene.add. Well, actually, we want to set node.left's value first, I think. So that should be equal to node.val times 2 plus 1, according to what they want. And then, well, we want to add that value in. Then we can traverse node.left. And we'll do something similar for node.right. So I'll just copy this. Yeah, I can just do that, and then let's see. Yeah, just turn all of these to right. Except we have to change this. So at the end of this traversal, we should have all the values added to scene. So we just need to do, I think, traverse root, and then like we can just return afterwards. We don't actually have to do anything here. Yeah, and then here it's very simple. We just return target in self.scene. Oh, that's not good. Oh no, what happened? I think my Wi-Fi died. Well, I'll just connect to my hotspot for now. It seems like